Well, hello. My name is Ann Hamlin, and I'm a professional development coordinator with Northern Arizona University's Center for Science Teaching and Learning. And I am a learning expert on the Planets Project. So I make sure that everything we put out there is easy to learn about and easy to understand. And joining me here today is Lori Pegg from the USGS. So you want to tell us about yourself, Lori?
Yeah, so I'm Lori Pegg. I work at the U.S. Geological Survey Astrogeology Science Center as a Pathways intern, and I'm a subject matter expert. So I mostly talk about all of the things we're trying to learn about.
Awesome. Well, yeah, thanks for joining us, Lori. And we have a question about the weather today, which is super interesting. We got a question submitted on our website from someone who wanted to know, are there hurricanes on other planets?
Yeah, this is such a great question because it made me think about what a hurricane is and how we think about it in planetary terms. So we define a hurricane as a windstorm that spins with wind speeds of over 74 miles per hour or 120 kilometers per hour that produces a lot of rain and thunder and lightning. And I started to think about, well, what if you had a planet where the average wind speed was over 300 miles per hour? Or what if you had storms that spin a lot but don't necessarily produce rain or thunder and lightning? And so in planetary terms, you could have these types of storms that aren't necessarily defined as hurricanes. And so some storms on other planets might be a hurricane just at under a different definition.
Oh, interesting. Like typhoons in the Eastern Hemisphere?
Exactly.
Cool. So what planets out there do have atmospheres and might have these kinds of storms?
Yeah, that's a really critical point, is that you have to have an atmosphere, something that produces some sort of circulation of the air and of some kind of water or gas and liquid mixture. So this beautiful picture behind me is of Jupiter and this amazing great red spot that we've been able to observe since about the 1600s. And Jupiter's great red spot is a circulating storm system that rotates, and it has incredibly fast winds, but it doesn't interact with the surface like a hurricane does with that evaporation and rain. So it doesn't have this water cycle or any form of interaction with the surface like a hurricane does. And it's also not seasonal. Our hurricanes are seasonal. And so without that rain and without any sort of ground to surface, I don't know that we can classify it as a hurricane in the way that we classify hurricanes here on Earth.
Right. Huh, that's interesting. So it's not coming from like a surface water or any other chemical, but are there other planets or moons in the solar system that do have any sort of liquid on the surface that might form a hurricane-like storm?
Yeah, so Earth is the only body with liquid water on its surface. There are other planets and moons that have liquid on the surface that's just not water. And so you'll get this water cycle like we have on Earth with some other liquid. So we have that evaporation, we'll have condensation to make clouds, and precipitation to make rain just with something else. Like on Titan, it has methane and ethane to make clouds of methane and rain of methane. And on Titan, they have storms, just like we have here on Earth, just made out of methane. They'll have rain and snow. And some storms on Titan can be extreme by Titan standards. It'll have wind speeds of 22 miles per hour that on Titan is very fast, but here on Earth, that's nowhere near hurricane type winds. So on Titan, that might be an extreme storm, but here on Earth, that's just an average thunderstorm.
Wow, that's really interesting. Huh, it's crazy to think about. Cool. Well, thank you so much for joining me and answering that question today. It's super interesting. Yeah, so thanks, Lori. And then if any of you guys have questions for our subject matter experts, you have questions about what happens on other planets, then put it in our website. So we have planetstem.org, and there'll be a link to it with this post. And we'd love to hear from you. Bye, everyone.
Thanks, everyone.